Hello dear students, hope that you have written the self-assessment test very well. Now we are reaching to the end of the session. We have completed our syllabus. So in this video, we will have a revision on the chapter Exponents. In the chapter Exponents, you know that only exercise 4.1 is in the syllabus. So we shall discuss some basic ideas about exponents and some questions from exercise 4.1. So what are exponents? We know that the repeated multiplication by the same number can be expressed in the form of an exponent. So here we can see certain examples. 2 is multiplied by itself repeatedly 4 times. Hence it can be written as 2 to the power 4. Here the number multiplied is the base. Here 2 is the base and the number of times 2 is multiplied is the exponent, that is 4 is the exponent. Similarly, we have 3 to the power 5, minus 5 to the power 3 and 3 by 4 to the power 4. Any number can be multiplied repeatedly, various number of times, so they can be expressed in the form of exponents. Hence, we can define the exponents as follows. If a is any rational number and n is any natural number, a multiplied n times by itself, that is a to the power n, is known as the exponential form, where a is the base and n is the exponent or index or power. Note that the bases and exponents can not only be rational numbers or natural numbers, but also be irrational numbers or real numbers. For example, a base can be either negative or positive, a fraction or a whole number, or an irrational number. Similarly, an exponent also can be a positive or a negative number, a fractional, a rational or an irrational number. You will study about those exponents in detail in the higher classes. In class 7, you have only a as rational number and n as a natural number. We have also studied special exponents. An exponent with power 2 is known as a square. An exponent with power 3 is known as a cube. So a square is the square of a cube is the cube of a. Similarly, we have exponent with power 1. An exponent with power 1 will give the same value of the base. That is, a to the power 1 is equal to a. For example, 5 to the power 1 is equal to 5. Minus 6 to the power 1 is equal to minus 6, etc. Let us go through few examples. We have minus 2 to the power 7. We know that it is minus 2 multiplied 7 times by itself, that is minus 128. Then minus 6 to the power 4 is 1296 and 2 by 3 to the power 4 is 2 by 3 multiplied 4 times by itself, and that is 16 by 81. From the first two examples, we can note down one more thing. When a negative number is multiplied odd number of times, the product is negative, and when a negative number is multiplied even number of times, then the result is positive. Moving on to some more simplifications, we have minus 3 square into minus 5 square, that is equal to 9 multiplied by 25, that is 225. Then minus 3 into minus 2 to the power 3, that is minus 3 into minus 8 is equal to 24. Then we have 25 square into minus 1 to the power 100. Here 25 into 25 is 625 and we cannot write minus 1 100 times. Therefore, we have to apply the rule of odd power or even power. Here we have a negative number to the power 100. That means the power is even. Therefore, we will get the result as positive. Hence, when we multiply 1 100 times we get 1 itself, and since the power is even, we have a positive result. Therefore, minus 1 to the power 100 is 1. Hence, 625 into 1 is equal to 625. We can also express the prime factorization of numbers in the exponential form. First of all, we have to do the prime factorization of numbers. Here we have an example 2280. The prime factorization is 2 into 2 into 2 into 3 into 5 into 19. Here 2 is multiplied 3 times. 3, 5 and 19 are multiplied only one time each. That means we have 2 to the power 3 into 3 to the power 1 into 5 to the power 1 into 19 to the power 1 in the form of exponents.